Yeah, very good morning. Am I audible?
Yes, sir.
Okay. Are you able to see the screen?
Yes, sir.
Okay, fine. Thank you. Yeah. So, the last class we have discussed uh, an example which essentially gives you volume of a solid, and where uh, uh, the the following example, right? That where we have seen how to identify or how to find the volume of the prism whose base is something is the triangle, okay, bounded by these lines, and uh, the top of the prism lies in the plane z equals to this, and I also we tried to find out how to design this prism, how to find out all the three corner points, and how to identify the limits, means whether if you are talking about y as a the limit of y as a variable, or because one of them should be variable limits because of the nature of the domain or which it is defined. Okay, so that we have also discussed in detail, that how we will look differently, and I think I have given you an exercise that along one of the limits, you have to verify that other value will also be will give you the same value. Okay, volume will be the same. Okay. So we have discussed those things, and so that's the unit volume. Okay, and I have asked you to verify the following. I hope you have done that exercise. Okay, so now uh, let's discuss the following examples which require some special attention. Okay, because of the type of this problem. So I will go one by one. So let's first example is where we want to solve this double integral, where the integrand is like sine x by x. Okay, sine x by x, and the limits are dx dy. So you have in order dx dy, and the limits are x limit is y to 1 and y limit is 0 to 1. X limit is y to 1 and y limit is 0 to 1. Now, it is easy to notice from here that, see, that you have to first integrate with respect to x and then with respect to y. Okay. Now, also it is, I hope it is well known among us that for this antiderivative does not means like you, it is not easy to identify the antiderivative for such function sin x by x. I means like we cannot apply fundamental theorem of calculus, right? Somewhere you have seen some right, some version of the fundamental theorem of calculus in case of single variable. Okay, so on the other hand, also you can look at the complication of this function sin x by x. Other way is like you will write someone may say that why can't we write sin x as Taylor series and get cancel, and you have polynomial and you have the infinite series summation. Now the question is uh, that's true, you could do that, but the thing is here, the challenge is when you're writing an infinite series, okay, n equals to, let's say, 1 to infinity, somewhere is like some function of or you have somewhere function of x only, means like some expression must be there. Okay, so if you have like this, okay, x to the power, let's say, n by n factorial time nth derivative at, let's take Maclaurin series. Okay, what is the challenge here is you have this integral sitting on the left of this, and integral is an operator. Now, the situation here is not like finite sum. It's like when you have function f of x plus g of x, if you have a finite sum of two functions, and if you apply the integral, you can easily evaluate by linear property integration f of x plus integration of g of x. Okay, this can be extended to finite sum with f1, f2, f3, and so on, fn. Let's finite. But whereas when you have an infinite series, it's a means how do we have understood this infinite series as a limit of some limit of sequence of partial sums, nth partial sums. And so whether now it is questionable whether we can interchange this limit and integral. Means we can we write this integral of limit n of something? Can I write as this limit n and then first take the integration, then apply the limit? The answer is not true. Answer is that is not true in general. You can't interchange this. What you require some conditions that somewhere like uniform convergence of the infinite series and so on. Okay, so what I want to make you understand, yeah, though it is see, sin x Taylor series is a very nice series. It is it's a part of right, e to the power ix, right? It's a real or sorry imaginary part of e to the power ix, or you can it's like so far you have not introduced the complex variable, so I should not talk about e to the power ix, but sin x series you have seen that's going to be summation x to the power some 2n plus 1, or it's like 2n minus 1 by 2n minus 1 factorial, and then some alternative plus minus sign somewhere minus 1 to the power n plus 1. Okay, n equals to 0 to infinity. So this Taylor series is a nice one. So somewhere you can do that, but in general you can't do this interchange of infinite series and integral. That's what I want to make a comment here. So we have to drop that idea and we should learn if there is any alternative of it. Okay, so let's for finite sum, it is perfectly valid, not a problem. You can take integral inside or outside, that's not a problem. But for infinite sum, it is challengeable, or you should have to attach some nice properties to the infinite sum, and then only you could do that. Okay, such nice properties, I don't know, I think we have covered only convergence there. Okay, not uniform convergence, but definitely it is required when we talk about the solution of partial differential equations. So there it will come, Fourier series will come. So there we will discuss some uniform convergence of infinite series. So for time moment, so let's postpone it. Okay, right. So what is the alternate here? So the one alternate possibility is it can we identify a reason in other way, means like first with respect to y and then with respect to x. So for that you have to be careful in drawing this reason. Okay, so here reason is r, where x is lies between y is less than equals to x less than equals to 1, and y is lies between 0 less than equals to y less than equals to 1. Set of all pairs x y such that is happening. Now if you draw this, okay, so how will you draw? So x y is 0 to 1, and 0 to 1, what this is y equals to 1 and this is x equals to 1. Okay, right. So now it is running from like x equals to y to x equals to 1. Okay, so this is what is happening here. Okay, so what so x equals to y is the line. Okay, x equals to y is the line. Okay. So this is x equals to y or y equals to x. Okay, so you are running, so you are entering from here, x is running from x equals to y, you are entering and leaving at x equals to 1. Okay, you are exiting from this. Okay, and y is running from 0 to 1, so means like y is entering from y equals to 0 and y equals to 1 is leaving this line. Means like you are drawing a straight line, okay, parallel to y axis for getting the limit of y, and you are drawing a straight line parallel to x axis to getting the limit of x axis. Okay, limit of x variable. Okay, so we have drawn those. So can we find equivalent limits for this? Of course, yes. Okay, so what you can do when you have So now again, if you look at in the variable limits, okay, so what is there is if you draw the for y, you want y variable limit. So for y again, you draw the this line, okay, that straight line, okay, parallel to the y axis. So it entered it y equals to 0 to y equals to x, right? So this is the line. So it enters to y equals to 0 and leaves at y equals to x. Now for x now, so for x now means when you are passing through it, because you have already covered this line over this line. Okay, so you are starting with here x equals to 0 to x equals to 1. Okay, so you have the another reason, equivalent reason is set of all pairs x y such that 0 less than equals to x less than equals to 1 and 0 less than equals to y less than equals to x. Now, so these two reasons are equivalent. Okay, now let's say this is I. So now I can write this I is equals to, so I equals to now, so 0 to x and 0 to 1 sine x by x, first with respect to y and then with respect to x. Now, when you are integrating with respect to y, this is a function of x only. So you have to treat this as a constant. Okay. So what is the integration? Y times sine x by x, 0 to x dx. And now integration 0 to 1. Now it is easy to solve. If you put upper limit, lower limit will not contribute. Y equals to 0 to y equals to x. So y equals to 0 will lead to only 0 number. Okay, y equals to x will lead to sine x. And now I put, now it is integrable. Now sine x integration is minus cos x. And you have 0 to 1. So minus cos 1 plus cos 0, that is 1 minus cos 2. So this is the final value. So earlier it was not solvable when you have to first integrate with respect to x, then with respect to y. Now it is easy to solve when you change the order of integration. Okay. Now, similarly, look at the other one. Okay. Look at this second problem. Okay. Now let's discuss here itself the second problem. Okay. Or let me write it. Okay. Sine y square, right? So let's have second problem. So you have I equals to integration of sine of y square dy dx, and limit is x to 1 and 0 to 1. X to 1 and 0 to 1. Now, again, if you draw this region, okay, x and y, and this is 1 and this is 1 and this is y equals to x. So for the y limit, it is going y equals to x to y equals to x, it is entering, and y equals to 1, it is leaving. And x is running from 0 to 1. So this is the part of the rectangle. This is the reason. Now, if you want to look in other way now, so you have 0 less than equals to y, less than equals to x less than equals to 1, and x less than equals to y less than equals to 1. Okay, now what you can do? So from here, now you want x variable limit. So for x variable limit, you have to enter like this. So x equals to 0 to x equals to y. So if I have, this is R1 is equals to x comma y, such that x is entering from x equals to 0 less than equals to x and less than equals to y. And then y is start from 0 less than equals to y less than equals to. Okay, so now how it will help you in this integral, this reason, this R1 also defines the same reason and R also defines the same reason. So this implies I equals to integration 0 to y, 0 to 1, sine of y square. Now with respect to x first and then with respect to y, right? Yes. So now integration 0 to 1, integration of this with respect to x is x times sine of y square. Limits are 0 to y dy. Lower limit again does not contribute anything. So I think now it is 0 to 1 y times sine of y square dy. Now you know y square derivative is 2y dy. So let's put 2y, 2 multiply and divide. So you know it's a derivative of, right, cos. Cos, if you derivative minus cos, right? So it's going to be 1 by 2 times minus cos of y square and 0 to 1. So this is equals to again 1 by 2, 1 minus cos. Okay, so this is the value of this integral. Okay, right. So this is how the change of order of integration helps you to solve a complicated integral even. Okay, though means you have to be careful in identifying these limits. Okay, now like we have studied the properties of uh, integrals which are for single variable cases. Similarly, the properties of double integral also have the similar features here. So let's have this. I'm stating here. Okay, then so f and g, two continuous functions on defined on the same domain D. Okay, and let c be a constant. Now you can take always, if you take scalar multiple of a function and double integral over it, you can take always constant outside like a single variable case. Similarly, double integral performs a linear operation when you have sum of two functions or difference of two functions. And if you are integrating over the entire region, you can do individual integration and then perform respectively sum or difference. Okay. Now, this is the important additivity, this property. Okay. So suppose you have a complicated geometry. Okay. Means okay. And you have somewhere is a like circular shape and somewhere is a conic, okay, section. Okay. So means you can divide the entire region into two. Okay. D and R. So total region is D union R here over which you are going to integrate. Okay. So not that here D and R does not have anything in common. Okay, so they don't have anything in common. So we are partitioning the region or in a disjoint sets, you can say. Okay, so D and R, D union R will give you the complete region. Okay, and so you have this, then you can perform the double integral over D and double integral over R separately, and then perform the sum will give you the double integral over the entire region. Okay, so here it's mentioning that D and R are non-overlapping domains. So that's what I mean. Okay, right. Now, other property is like domination. We have seen that in the single variable case, right? F of x is less than equals to g of x on for all x in closed interval AB. Means the curve F lies below the curve G. Okay, or the defined over the interval a to b. Then their area will also be relative. So integration a to b f of x is less than equals to integration a to b g of x dx. Similar here. Similar here, when you have one surface is lies below the other surface in a domain D. So over the domain D, so you have two surfaces. One surface is here and one surface is here. Okay, and you are measuring the, you can say, volume. So definitely the volume bounded by this and this are related, and that is in the similar fashion. Means f of xy is lies below the g of xy. So the double integral df of xy dA is less than equals to double integral dg of xy dA. Okay, now if you replace f of xy equals to 1, what it will give you represent the area of the domain. Okay, so I hope that is easy to get. Okay, because this dA is nothing but the area element. And if you perform it over the entire domain, it will actually covers the whole area of the domain. Okay, right. Now this boundedness will follow from this. Very straightforward. Okay, so m less than equals to f of xy less than equals to capital M means like you have here let me have here. So you have the following situation means you can say. Okay, so you have the following situation. You have the surface here. Okay, and you have a small m is like this and capital M is like that. Okay, so if you have m is bound means f is bounded or means on these lines you have z equals to small m here, this is z equals to capital M. Okay, so m time area small m a time areas you can perform again double integral over it. So this is again a see what you have, this is z equals to m and you are stretch it along the xy plane means it will generate a plane z equals to m. Okay, and if you find the area over this or volume over the region D, it is nothing but m time area of domain. Similarly, this capital time. Okay, and this is related with the double integral of f in this. Okay, right. So, okay. Now, because see, we have also talked about somewhere polar coordinates. Okay, so I hope uh, that is so let me just give you that Cartesian coordinates means like you have a Cartesian system. So you have a xy plane, okay, and you can always transform this x comma y to r comma theta plane, okay, r theta plane. Okay, which you can see over the xy plane itself. Okay, by by relation x equals to r cos theta, y equals to r sin theta. So from here you have you can easily identify x square plus y square equals to r square, and you have theta equals to tan inverse of y by x. And if you want to look at here, what does it mean is nothing but R is nothing but a ray. Okay, or not a ray. R is the this radius of the circle. Okay, theta will define a ray. Okay, if you have let's say fixed theta, okay, then you will have a this is a ray. Okay, so now this length is R. You can easily identify the coordinates of this. Okay. These are easy to identify the coordinates x equals to r cos theta and y equals to r sin theta. Okay, so because this length is r and you have this angle is so this no, not this angle should mention that the angle made with the positive x-axis. Okay, angle made with the theta is the angle made with the positive x-axis. Now you can use this result here. So to find the coordinates here, okay, this coordinates. So this is the length is r for this. So this divided by this, what it will give you? Hypotenuse, right? Divide perpendicular divided by hypotenuse will give you sine theta, right? So so this divided by so this is equals to, so you have this is OAB, you can say. So you know, right? AB divided by OB is equals to sine theta. Okay, so but OB is R, so you have AB is equals to R sine theta. So that is x equals to R. Wait a minute. This is okay. if you have this angle theta here made with the positive x-axis, so this is going to be AB divided by OB is equals to sine theta. That's perfectly fine. So AB is equals to R sine theta. It's correct, right? And similarly, OA will be equals to OA is equals to R cos theta. Yes. So, oh yes, yes, yes. OA will, this will be X, right? This will be Y. So I was correct. So this is X equals to R cos theta and Y equals to R sin theta. This is the height, right? On the, so this is the point we'll give you from here, and this will be here. So from here, X equals to R cos theta and Y equals to R sin theta geometrically. Okay. So that will define the polar coordinates. Or not that this 0, 0 origin. Okay. So at origin, this theta will not be defined. Okay, because 0 by 0 form, okay, is indeterminate form. So that you should keep in mind when we will talk about if sometime is like complex variable, maybe later on, maybe next to next semester. I don't know when it is going to happen, but okay, there you will look into more detail that what are the means whether this is a 1-1-on-2 transformation or from where to where. Okay, right. So that we will have more detail in during the complex variable sessions. Okay. Okay. So this is how you can always transfer the Cartesian coordinate system into polar system. Okay. Now, so this is how means this polar rectangle will take place. So what it is, I have you done polar coordinates during this single variable cases? Can anyone answer? I am able to remind that means I think we have done it.
Yes, sir. Some part, some questions.
Some part. Okay.
Some
Right.
questions
So
we have
okay, fine. Okay. I think some tracing and all maybe.
Yes,
Cloud
sir.
tracing maybe. So how do you define the polar rectangle? That's the first question now. Okay. So you have theta is the angle, and so in, you have this is xy plane again, and so you have, if you have two rays, you can define theta equals to, let's take alpha, and you have another ray is, let's say, theta equals to beta. It's not a straight line, please bear. Okay, so this angle is beta. Okay, so this is the angle theta. Okay, so theta equals to alpha to theta equals to beta. So that's what alpha less than equals to theta less than equals to beta. So there are two rays. Okay, now you have this is the this they have all the distance. This is R. This is R. Okay, so R is means you have let's take here theta is there. Okay, and R can be you can have the R limit as well, right? A to B. Okay, A is somewhere A is less than equals to R less than equals to B. Okay, in R theta. Okay, now how would you so this is called the polar rectangle. Okay, this is how you can define the polar rectangle. R equals to A to R equals to B. So here you can say here R equals to here is right. I mean, how do you let me have it here. Let's see. Yes, okay. So it's not R equals to, it's going to be R equals to 0 to R equals to B. Yes. So I was correct. Okay. So this is a this is simple polar rectangle. Okay. Let's try to find out what will be the area of this. Okay, area of this polar rectangle. How do you find out the area of this polar rectangle? Can anyone tell? Can I Can I have an idea? Can I implement that fact that area of the circle is pi r square here? Okay. Area of the circle is pi r square, right? The radius r. That's very well known. Okay. Now this is the area when the theta is from 0 to 360 degree. Okay. So this part can be given by, you have, this is so in radian it is 3 by 2, 360 is 2 pi, right? So theta by 2 pi time pi r square will give you the area of this part. So that will give you 1 by 2 r square theta. So that will be the area of this polar rectangle can be defined. What about the length of this circular arc? I can use again the idea of means like that circumference, right? 2 pi r. Right, over the 360 degrees. So I can just multiply by theta by 2 pi. So that's going to be r theta. Okay. So that's it. That's this is the length of the circular arc, and the area of this polar rectangle is this area is this, I should write A of r. Area of this region is going to be 1 by 2 r square theta. Do anyone have doubt here? I think it's very easy to follow. Okay, right. So the area of this this polar rectangle is 1 by 2 r square theta, and this length of this circular arc is nothing but r time theta. Keep in that mind now. Okay, right. So now since see it is so I have introduced a very simple rectangle which is starting from r equals to 0 to r equals to b. Let's take r equals to a to b. Okay, so here is that rectangle. Let's take this is r equals to a to r equals to b. Okay, and theta is lies between alpha to beta. Now I want to identify the double integral over polar coordinates. Okay, when you transform it into polar coordinates, how the limits will look like and all and so on. Okay, so suppose a function is defined over the polar rectangle. Then you will proceed in the similar fashion as you have done in the Cartesian coordinate. You subdivide again by means of partition. So you can see by meaning of partition of theta. Okay, so theta j minus 1. So you see theta j minus 1 to theta j. So whenever you are taking theta equals to theta 1, theta 2, theta 3, and so on in between. Okay, so if you have alpha equals to theta naught, you can say, and beta equals to theta n or m, whatever you want to, like final value. Okay, and in between you have theta 1, theta 2, and so on, theta m minus 1. What does they mean? I've told you already, theta 1 is the angle, theta 2 also angle, theta m minus 1 also angle. So they will identify the rays. Okay, they will identify the rays. Okay, they will identify the rays in between this. Okay, and now similarly, when you talk about the r partition along the r direction, so you have let's take r naught equals to a and rn equals to b, and rest of their points are r1, r2, and so on rn. So they are they are lies over the interval a to b, means they are going to be like this. Okay, it's somewhere like, okay, you are subdividing into smaller polar rectangle. Now denote this the length of any means like, so then I am just now marking this polar rectangle. Now here you can see, I hope this is easy to see, that this is what? What is this? This is circular arc. R equals to, this is given here, R equals to Ri minus 1. Okay. Now, another one, this one is a circular arc, R equals to Ri. Means like made by this. Okay, we will find out the length of it. Now, similarly, you have, this is theta equals to theta j, and this is theta equals to theta j minus 1, the ray part. Okay, so the angle, what is the angle now? So because we want to identify this length of this circular arc means you can say the area of this rectangle. You want to verify. Okay, how do you find out? So up to here, over this is going to be I can define this d theta is equals to theta j minus 1, and let's take dr equals to ri minus 1. Okay, let's denote this. Now you are interested in finding the area of this. So now first, with respect to r equals to ri, what is the area? What is the area covered by the angle d theta? Just now we have learned 1/2 ri square d theta, right? Because the angle is d theta. Similarly, here, what is the area of the this polar rectangle? The lower one is going to be 1/2 r, because it's going to be the r equals to ri minus 1. So ri minus 1 square d theta. So what is the area of this interior one here? Is nothing but this minus this. So this will give you the area of this polar rectangle. Into the height of this f of r comma theta again will denote the height of it. Okay, and that will totality it will give you the volume. Okay, so now you can simplify it. So what is the area of this polar rectangle Rij now? I must say now Ri is equals to 1/2 Ri square d theta minus 1/2 Ri minus 1 square d theta. So this is equals to 1/2 Ri square minus Ri minus 1 square d theta. This is what you see. This is something like similar fashion, like when you have fx is a lower upper curve and g of x is a lower curve, and you area under the curve f minus area under the curve g. Okay, that will give you the area between the curve f and g. Okay, it's a similar fashion. Okay, so this is going to be, I just write 1/2. I can rewrite this as a minus b into a plus b. So ri plus ri minus 1 into ri minus 1 is dr d theta. You have means what is the meaning of here d theta and dr means we are taking right now equispaced. Okay, means uniformly spaced. Okay, means all lengths are similar, same. Now, as I and j tends to infinity, this tends to r times dr d theta. Why? Because when you have I and j, if you increase number of partitions, ri and ri minus 1 will get closer to each other. Okay, as n tends to infinity, this ri will be almost equal to ri minus 1 only, and that is nothing but we are going to denote it by r only. So 2r will come, so 2 will get cancelled. So that r, so the change in the region, okay, in the polar form is going to be obtained by r times dr d theta. So what does that mean is dx dy should be replaced by r times dr d theta when you are changing the polar coordinate.
Sir,
Okay, yes.
sir, but it is a rectangle. Like in the previous slide, you showed us that it was a rectangle. So why can't we just take
It is
length
a-
into breadth?
It is a polar rectangle. Oh, okay. If you have length and breadth also, that's also fine. So polar rectangle.
Yes, sir. So length is dr and breadth is d theta. So won't it
No,
be
no, no,
just
no, no.
dr d theta?
No. The length of the circular arc is not dr. Okay, it is going to be r time d theta. I will show you. I just parametric equals the circumference we have seen, right?
Okay, sir. I understood it.
Okay. So that's why I
Yes, sir.
discussed. I have introduced both the things. Like when you interested in only length into breadth also, that also fine. Yeah. So this is a again, I just want to mention here, this is a polar rectangle. Okay, this circular arc length is nothing but r d theta. Okay, just now we have discussed here r theta here, right? Because theta is the angle between these two rays. Okay, so there is an angle d theta. So that length is nothing but r d theta. Okay, and this length is nothing but ri minus 1. That is going to be dr. So r d theta dr. Again, you will obtain the same thing. Okay. Yeah. So this is how this double integral in polar coordinates means like you have this. Okay, fine. So like what I have told just now, we can have here in some words. Suppose f is a real valued function defined on a polar rectangle R. So you can, again, I have told you, you have to partition that polar rectangle along R and along theta. Okay. Sorry. Okay. So then I have shown you the area of the rectangle, polar rectangle Rij is nothing but this is going to be this. And taking uniform grids, so you define delta r equals to this and theta into n equal part with delta theta is equals to this. So you replace this by delta theta, del theta, and this is ri minus 1 is del r into ri plus ri minus 1. I have already shown you. And then if you increase number of partitions, then this will sum. And if everything is fine, means like f is continuous function. Okay, we are making that sure that summation will converge because it double sum. Okay, it's going to obtain double sum. So this will be double sum. You can tag a point by using the Riemann sum and so on. Okay, and if f is continuous on polar rectangle R, then you have this double integral R f of x y dA is equals to following. So you have to keep in mind that dx dy, the area element, is changed into now r time dr d theta. Keep in that mind. So it is not like dx dy is replaced by dr d theta. Okay, so there is a change. Okay, right. And how it will make your life simple while solving a complicated integral, we will see in some examples. Okay, right. Now let's first let's talk about, if you have, suppose instead of you have non-rectangular region, means like in polar form you have a non-rectangular region. Okay, means means you have the rays for theta. Okay, you have the rays for theta as like we have seen in Cartesian form, but r is not bounded r equals to a to b. It is going to be r equals to some function of theta and r equals to some other function of theta. It is bounded between them. Okay, so again, I am not going to that detail. You can this again, that Fubini theorem will take into the place here, that stronger form or second form, and you can alternate, means and finally you will obtain the following formula. I just want to say here, dA, the area element, again, so like we have discussed in Cartesian form, we have devised a non-rectangular region into rectangular grids by drawing the vertical lines parallel to x-axis and y-axis, and as the number of points increases in the each partitions, or if you are making them as large as possible, and if f is a continuous function, that will actually goes to the double integral. So similar concept can be applicable here, and you can have, because since r has a variable limit, so first you have to integrate with respect to r, then with respect to theta, and r is bounded by the curve g1 to g2, and theta is from alpha to beta. Okay, so I'm not going to discuss much here, okay, regarding this. So it also have the same theory, okay, like a Riemann approach. Okay, so let's discuss this problem. In the first problem, we are supposed to identify the limits of integration for integrating f of r comma theta over the following region. Okay, the very first thing is, first you should get that how this region has been designed. Okay, or how will you identify this is going to be the reason? Okay, that you have to first try to look into the region and try to relate the equation of the curve. So if you look at carefully, it is saying that that's a cardioid r equals to 1 plus cos theta, and outside the circle x square plus y square equals to 1. So the circle is easy to draw. So you can draw the circle, right? X square plus y square equals to 1. That's easy. Okay, that blue line. So this is a circle. Okay. Now, how will you get this? See, theta is always lies between 0 to. So now, one thing is there on the x-axis. What is the angle made by the theta? Is going to be 0 with the x-axis. So theta equals to 0 will give you cos 0 is 1. So 1 plus 1 is 2. So on the x point, you can locate them. On the y-axis, you have theta equals to pi by 2, right? This is the angle pi by 2. Okay. So when you have theta equals to pi by 2, r equals to 1. So on the y-axis, it is the 1. Okay. Now, if theta equals to pi, what will happen? So theta equals to pi. When you further move, okay. So theta equals to pi means cos pi is minus 1, right? 1 minus 1 is 0. So r equals to 0. Means you are going here, right? When theta equals to 2 pi, cos 2 pi is, yes, 1. R equals to 2. Right? Cos 2 pi is 1 and r equals to 2. Now, what about theta equals to minus pi by 2? So, because see, you can also, theta equals to minus pi by 2 is, means when you have this side, you can make this angle as pi by 2, and this side is minus pi by 2. Okay, so theta equals to minus pi by 2 means you are going this, okay, you are moving clockwise. Okay, right? So theta equals to minus pi by 2, r equals to again 1. Okay, and then theta equals to you have this is going to be what again it will come into the picture here, 0 to pi by 2. Then you have when you have theta equals to, yes, we have taken all the things, right? 0, pi, pi by 2. Yes, right? So there is cos 0 is 1. Okay, that we have already taken, right? 0, pi, 2 pi, and so on. Fine. So somehow we have located these 3 points at least. And then we know this is a curve, part of a type of a circle, it's like circular arc. Okay. So it's going to be a continuous. So it means roughly we can draw at least, or you can identify theta equals to 45 degree. Okay, and you can you can make that point as well to join that. Okay, and so you can trace this curve. Okay, roughly at least. Right. Now we want to, so we are interested in finding the limits because we don't have any expression for f of r comma theta. So we are not interested in solving the integral, but we are interested in finding the limits. So it is saying that region R that lies inside the cardioid and outside the circle. We are talking about this region. So it is very clear that theta limit is from minus pi by 2 to plus pi by 2. So when it is not mentioned, means always it is taken in the anti-clockwise direction. So you have theta limit is minus pi by 2 less than equals to theta less than. For R limits, you can see that at any, so R will enter from here and exit from here. Okay, so at any point here, R value is 1. So if R equals to 1, 2, it will leave 2 from here. So at here it is 2, but here and here it depends on, entirely depends on theta. Okay, and how it is related? R equals to 1 plus cos theta. So R equals to 1 to 1 plus cos theta. These are the limits. So final expression is minus pi by 2 to plus pi by 2 and integration 1 to 1 plus cos theta f of r comma theta r time. So this is for r, so dr d theta. Okay, so this is how you can identify the limits here. Right. Let's take one more example. Let's look at this second problem. We have to evaluate the following. Okay? So let's take I is equals to integration 0 to 1, 0 to square root of 1 minus x square plus y square, dy dx, right? Yes. Now, if you directly try to integrate, I think it is possible, 0 to 1 and x square y plus y cube by 3, 0 to square root of 1 minus x square dx, upper limit minus lower limit, 0 to 1, x square, lower limit will not contribute anything, 1 minus x square plus 1 by 3, 1 minus x square to the power 3 by 2 dx. Now, what about further? Further, you need some a table, right? Square root of a square minus x square. How will you integrate? You have to look at those formulas so that you can work out. Now, on the other hand, if you look at the region, okay, if you look at this region over which it is integrated, okay, so this is nothing but the first quarter of the unit circle. Okay, so this is nothing but, right, x equals to 0 to 1 and y equals to 0 to square root of 1 minus x square. Okay, so this is the R. Now, in the polar form, what it is? So when you have x equals to r cos theta, y equals to r sin theta. Okay, so here it is, I hope that is easy to get now at any point of this R. So, okay, at any point, you take any point on this, R is always 1. So, R is 0 less than equals to R less than equals to 1. And theta limit is from 0 to pi by 2. So, 0 less than equals to theta less than equals to pi by 2. So, this first quarter of the circle is mapped onto a rectangle, okay, in the r theta coordinate system. So x and y, and if you look at the polar coordinate system, in polar coordinate system, it is r, let's say theta, r equals to 0 to r equals to 1, and theta equals to 0 to theta equals to pi by 2. So this will be a rectangle in r theta coordinate system. Okay, so geometry becomes simple here. Okay, now carefully I can now, so therefore I is equals to integration 0 to 1 and integration here. So x square plus y square, x square plus y square. You have to change x equals to r cos theta, y equals to r sin theta. So it's going to be r square. dy dx, the area element is replaced by r times dr d theta. Now, Fubini's theorem tells you, because this is a rectangle, right? Finite limit 0 to 1, 0 to pi by 2. So you can integrate in any, okay, with respect to r first or with respect to theta first. So here you can you have 0 to 1 and 0 to pi by 2. And then see the integral becomes simple now. So r cube integration is r to the power 4 by 4. R to the power 4 by 4, 0 to 1 d theta, and that is going to be 1 by 4 upper limit minus lower limit into pi by 2. So the final answer is pi by 2. So it's a 1 or 2 line per problem. Okay, once you change into the polar coordinate system. Okay, right. Now, similarly, I will give you an idea of the third problem. Okay, so third problem says you have to integrate double integral r, where r is the region in the upper half plane bounded by the following circles. Now, if you are insisting yourself, okay, to solve by in Cartesian coordinate system, so the limit of r means in x and y. So if you want to have the y limits, okay, y limit is from here, it enters here and it leaves here. Okay, so square root of 1 minus x square less than equals to y less than equals to square root of 4 minus x square. Okay, so that's a y limit, and x limit is from here to here. So 1 less than equals to x less than equals to 2. Okay, so it enters here and it leaves here. Okay, so these are the limits when you are trying to identify in form of Cartesian. Now, on the other hand, if you are in polar form in r theta, now you know x square plus y square equals to 1, x square plus y square equals to 4. You can use x equals to r cos theta, y equals to r sin theta, dx dy is replaced by r dr d theta. You have to replace everything here carefully. And this reason are now in polar form. What is that? So from here, r is 1, right? If you look at in the polar form, is r equals to 1 at any point, and here is r equals to 2. So r limit is 1 less than equals to r less than equals to 2. And what about theta limit? Theta is equals to 0 to theta equals to pi. So 0 less than equals to theta less than equals to pi. Now choice is yours which way you want to go to solve this integral. Okay, both value will be the same. Both will lead to the same value. Okay, so that will not come different. Okay, right. Okay, now let's take one more example. Okay, so find the volume of the solid. Okay, find the volume of the solid that lies under the paraboloid z equals to x square plus y square above the xy plane and inside the cylinder x square plus y square equals to 2x. You know, above the xy plane means this is always positive. So volume is what? Double integral over r z f of x comma y times dA. That will give you the volume formula, right? Now, the cylinder, right, is this x square plus y square equals to 2x. Now, if you have, this is what is given is z equals to x square plus y square. It's a paraboloid. So this is going to be x, y, and z. So you will have a like a circular bowl. Okay. Now, and means lies above the xy plane and inside the cylinder. Okay, cylinder is equation is given to you. So that is x square plus y square equals to 2x. Now, if you rewrite this, it's nothing but x square minus 2x plus y square equals to 0. And if you add 1 and subtract 1, okay, so what you will observe is going to be x. Wait a minute. So let's see. Look at this. Yeah, add 1 both side. Okay, yes. So x minus 1 whole square plus y square equals to 1. Right? Now, if you draw this cylinder, it's like you have how to draw the cylinder. That's very first thing. Okay, so you have, this is a, if you look at this is a circle centered at 1 comma 0 with radius 1. So you have, this is 1 comma 0 with radius 1. So you have this. Okay, this is x side. Now you stretch this circular curve along the z-axis. Okay, so that will generate a cylinder. Okay, you just stretch this curve along the z-axis, so that will give you the cylinder. Okay, so you have, this is here 1 comma 0 here center, and you have, this is the, and now you have to stretch it along the z-axis. Okay, so you have to stretch it along the z-axis and you will get some of the part here. So this is what it is here has happening. Okay, this reason you can look at it. Okay, so that lies under the paraboloid. Okay, so this is the reason you are solid, you are identified. Okay, now over the reason, what is the reason? Reason is nothing but this. So that you have to identify. So this is equals to double integral over R. F of xy is x square plus y square d. What is R? R is nothing but this circle. Okay. Now you can identify the limits. X limit is what? You can find out, right? It means x limit is, if you identify is 0 to 2, y limit is 1 minus square root of 1 minus, you have this is, if you enter here, you will leave here. So minus square root of 1 minus x minus 1 whole square to you have plus square root of 1 minus x minus 1 whole square. So that's a y limit. And that again, it looks complicated. Though now if you change it into polar form, that the things will be simplified. Okay. So if you use the polar form, okay, so if you use the polar form, how this cylinder will looks like is, so you have x equals to r cos theta, y equals to r sin theta. Okay. So what is x square plus y square equals to 2x? From here, if you replace x by r cos theta, y by r sin theta here, so it is going to be r square 2r cos theta. This implies r equals to 2 cos theta. Okay, so what it shows that r is entering from here and leaves here. So r equals to 2 cos theta. So 0 less than equals to r less than equals to 2 cos theta, and theta limit is, what is the theta limit? Yes, what will be the theta limit? Can anyone tell? What will be the theta limit? We have discussed many questions. So can anyone guess? Yes. Yes, anti-clockwise. R is here, so you are measuring everything from here. R equals to 0 to R equals to 2 cos theta. Can someone now guess? Minus pi by 2 to plus pi by 2. Okay, so the limit of theta is minus pi by 2 less than equals to theta less than equals to plus pi. Now you have minus pi by 2 to plus pi by 2, integration 0 to 2 cos theta. Now x square plus y square is r square time r dr d theta. So now you can integrate further, integration minus pi by 2 to plus pi by 2. So it is r cube. So r to the power 4 by 4. So 1 by 4 times r to the power 4, 0 to 2 cos theta d theta. Now you know how to solve this integral, such integral. So that's equals to, this implies I equals to, so 2 to the power 4 is 16. So it's going to be 4 times integration minus pi by 2 to plus pi by 2 cos to the power 4 theta. And you can use now definite integral property that because it's an even function, so you can write that 2 times integration 0 to pi by 2. So this is going to be 8 times integration 0 to pi by 2 cos to the power 4 theta d theta. And now you know how to solve this integral. You have to write cos square theta as 1 plus cos 2 theta by 2. Use that fact and you square it. Okay, and then replace again cos square 2 theta by, you can use that cos square 2 theta is equals to 1 plus cos 4 theta by 2. Okay, and solve this integral and get the final value. Okay, so I think now it is easy to get it. Okay, right. So you can find the final value of this. Okay. So now, so far whatever we have discussed, okay, the same thing can be extended to triple integrals. Okay. So I'm not going to be in detail for the theory part now, triple integral, how this Riemann sum approach will help you. Okay. So I'm just going to read out these things right now. So let f be a real valued function defined on a bounded region D in R3. Okay, as earlier, divide the region D into smaller cubes. So I told when you look into the R3 now, rectangular becomes, if you include the height as well, so cubic. Okay, and close by planes parallel to the coordinate planes. Okay, the set of obtained smaller cubes in step 1 is a partition. Okay? Now assume that this norm P is nothing but the maximum of the volume enclosed by such smaller cube. So if norm P tends to 0 means you are taking very small cubes. Okay. So, and then you have the summation will have now triple sum. Okay. You have a tag point. You have delta xi, delta yz, delta zk. Okay. Then if this limit exists, then you denote this by triple integral. Now, as earlier, what in the double integral, if the integrand equals to 1, was giving you area. Now, if you have here f equals to 1, it will give you the volume of the region D. Okay, so this is one, you can say, physical significance of triple integral. Right. So let's discuss these 3 problems. Okay, individually. Okay, and try to understand how to identify the limits. Okay, right. So first problem is find the volume of the solid enclosed by the surfaces volume. Okay, so solving the integral, I will leave it to you. I'm just going to discuss how to finalize limits. Okay, that is a crucial thing and you talk about. Okay, so you have find a solid enclosed by the following surfaces: z equals to x square plus z equals x plus y square, and another is z equals to 8 minus x square minus y square. Now, now let's draw these surfaces. Okay, so x square plus 3y square is looks like ellipsoid. Okay, ellipsoid. Now that it looks like, that is an interesting thing. So this is x, y, and z. Okay, so it's an ellipsoid. So I'm going to something like that. Okay. Now z equals to a minus x square minus y square. Okay, what it resembles? Okay, it resembles if you take x square plus y square more than 8, it becomes negative, means it will come down. Okay, means z equals to negative number, means it's going to this. Okay, right. So, but whenever x is 0 and y is 0, z is 8. X is it's like x square plus y square equals to 1. You have z equals to 7 and so on. It's a, you can say it's a reverse. Okay, reverse paraboloid. Okay, downward paraboloid. So will be looks like. Okay. So this is this. So what will be the solid here? So the solid formed by these two surfaces. Okay. Now you have to identify the volume. So means you are trying to triple integral dv over the region D. Now we want to identify the limits. How would you identify the limits? So first, I want to now go through dz, dy, and dx. Okay, I want to go through in this order. So now for finding the z limit, okay, you can draw a line vertical, okay, from xy plane to towards the z axis. So it is entering into this surface and leaving from here. So z limit is straightforward, x square plus 3y square is the lower one, right? Less than equals to z less than equals to 8 minus x square minus y square. Now for getting the y limits, okay, for getting the y limit, you draw a line parallel to x-axis. Okay, so so on the xy plane, so means see, for getting the limits of y now, we have to look at on the xy plane, how it will looks like. Okay, on the xy plane, what is the geometry? So on the xy plane is nothing but it's the projection of this intersection. So this intersection, they are meeting. Okay, so they are meeting at the point. So where it will meet is when you have 8 minus x square minus y square equals to x square plus 3y square. Okay, so this will give you 2x square plus 4y square equals to 8. So from here, x square plus 2y square equals to 4. Okay, so it's going to be an ellipse, okay, an ellipse in the xy plane. Okay, in an ellipse in the xy plane. Now, to identify the y limits means it is entering here and it is exiting here. So, and so from here, so where it enters, so y is equals to 1 by 2 square root of 4 minus x square with a negative sign less than equals to y less than equals to 1 by 2 square root of 4 minus x square. Now, for x limit now, it is entering from here and exit from here. So it is going to be, yes, minus 2 to plus 2, right? Minus 2 less than equals to x less than equals to. Okay. Now, if in other words, suppose you want to first find out the first find out the x limit and then y limit means then x is from here plus 4 minus plus square root of 4 minus 2y square to let me have this. So what is the reason? D. I will define the equivalent reasons. Okay, x, y, z. X lies between minus 2 less than equals to x less than equals to 2. Y limit is minus 1 by 2 square root of 4 minus x square less than equals to y less than equals to 1 by 2 square root of 4 minus x square. And z limit is x square plus 3y square less than equals to z less than equals to 8 minus x square minus y. That's the first one. That's another way is x comma y comma z. Okay. X is entering from this side and leaving from this side. So this is, if you look at in the reverse way, x is from minus square root of, so writing here minus square root of 4 minus 2y square less than equals to x less than equals to plus square root of 4 minus 2y square. Y limit is minus 2 to plus 2. Okay, minus 2 less than equals to y less than equals to plus 2. And z limit is same, x square plus 3y square less than equals to z less than equals to 8 minus. So anywhere means any domain you will integrate, you will get the final answer same. Okay, right. So if you have any question regarding this, you can ask how this means how this is the limit. Like we can debate on it. Because while evaluating the double integral or triple integral, so it is very necessary to get the correct limits. Otherwise, your answer will be wrong, or you will get into a complicated integral.
Sir,
Yes.
can you again explain the second one, D2?
D2.
Yes,
Okay.
sir.
So see, so see when so equation of in the means the domain in xy plane is this. That is fine.
Yes, sir.
Okay. Now we can look in different ways. It's like either first y and then x or first x then y. Okay. Now, if you want to go for first x variable limits means axis means you are drawing the line parallel to y axis. Okay. And you want to find the x limits means you are drawing the line parallel to x axis. Okay. Means and then you have to start from the negative side to increasing direction. Okay. Lower to upper one. So it is entering from here to here and exiting from here. So from here, you can definitely find out x square equals to 4 minus 2y square. You can definitely identify what is the equation of curve on this side. Okay, from where it is entering and from there it is leaving. So x equals to what? Plus minus square root of 4 minus 2y square. So if you rotate this axis and or you try to see the this is going to be minus square root of 4 minus 2y square, and this is going to be plus square root of 4 minus 2y square. So it is entering from here and leaving from here. So x is lies between here. Is that clear your doubt?
Yes.
Right? Then you have y. So for finding the y limit, you are drawing the vertical line parallel to y axis. Okay. Now it enters here and exit here. So means you fixing x equals to 0 and then finding y equals to 0. Y equals to plus minus 2. Y square equals to 4 by 2, right? Wait a minute. Just a minute.
Root 2
X
minus root 2
square plus yes.
minus root 2 to plus root 2.
Minus root 2 to plus root 2. Yes, correct. So here minus root 2 to plus root 2 is correct. I have got cancelled this 4, but I have not taken the square root in it. Yeah. Now it's correct. Yeah. Yeah, fine. So I think the time is up. So we can discuss more problems in the maybe next session in detail. Okay. And we can finish it. Yeah. Yes. Thank you. If you have any question, you can ask.
Thank you, sir.
Yeah.